Hi everyone and welcome back to the channel, and we're building a parametric Lego brick. And in the previous video we got to the part where we had just the base of the brick and one single stud. In this video we're going to be looking at creating the rest of the studs and the tubes and making it all parametric. So when we change the size of the length, everything else changes with it. So we can change the size and the width, and it will all conform to those parameters. We'll also look at creating this as a solid object, allowing us to use booleans, cuts and unions with this object, and also output that as a file that we can 3D print. So I hope you're enjoying this tutorial, and let's finish off this model. If you like what you're seeing, please subscribe to the site. I also have a Ko-Fi or a coffee site that you can donate to if you so desire, and that's at ko-fi.com/MANG0. I also run a Patreon where you can subscribe and get extra content, and that's at www.patreon.com/MangoJellySolutions. Any money that's kindly donated will be used to expand the channel. For the next part of this project, we need the Lattice2 Workbench installed. To install it, go into the tools and on the add-on manager. Once this loads, you'll find that if we filter by Lattice2, we have the workbench here, and this is just a case of clicking on it and installing it. Click on install, and what we'll need to do is restart FreeCAD once it's all installed and ready to go. So we have the Lattice2 Workbench installed. Let's start using it against this feature. Come over to the Lattice2, and what we'll see is a number of features across the top here. Now there are quite a few icons here, and if we look at the Lattice2, there's quite a lot going on in this workbench. We're only going to be using a few of these features for this project. I need to take this feature and array this across this way and then array it this way. So we get two going this way, and then those two will go this way, creating now 4 stubs. To do that, I'm going to use something called a linear pattern. And that's this one here, linear array. First of all, we make sure nothing is selected. And I'm going to use the drop down. The reason why I'm using the drop down is because these options are in the same location for everybody. Depending on your screen size, then the toolbars can jump about a bit, and not everybody's config is the same. I'm just going to go for the default linear array span/n. We can change these are all the same linear pattern. They're just different settings that are preset when you select them. They're always the same linear array. Because nothing's been selected, it's just been added at 0.00. So you can see the axis cross, it's just been added there, which basically is what we want. It's placed something known as kites. So these are kites, these are placement kites. And if we look at that linear array and bring this out a bit, you can see the number of elements there is set to 5, and that's how many kites we have there, 5 kites. I'm now going to use this fillet and place them against these kites. So first click the fillet, control click the linear array, and let's go to Lattice2, populate with copies, and then populate with copies, build array. So this will place a copy of that fillet. If we come in here, we can see the fillet has been made invisible against that linear array. By clicking on that linear array, we can come down and change the number of elements. So let's bring this out. You notice we've drilled into the populate linear array with fillet, this new icon in the tree view. So this is the result of our action. Click on the linear array and come down, and we see the count. So this can be controlled via the spreadsheet as well. So click on the formula editor and type in spreadsheet width units and hit OK. We'll click off, this takes effect, but at the moment it's too far away, so we've got to pull this inwards. To do that, let's select the linear array again and come down. Now this span n, you can see we've got the generation mode as span n, and we've got a number of different modes here. We're going to keep it with span n, and this spans the end, so we've got a start and end. So we've got from here to here. If we reduce the span end to 8, you can see it's pulled it back in towards the model, and you can see those kites have reduced in the space in between them. Let's add the spreadsheet value for this. So we come down to that length, that span end, which at the moment is 8, which is about right, and use the formula on the end. Let's have a look at our spreadsheet. We need to derive a formula for this. So we need to use the horizontal spacing and the length units. To make this easier, I'm going to change this length units, because at the moment we've got length units of 2 and a width units of 2. So let's change this length units to 3 so we can see the difference between those. So we're going to use the horizontal spacing times by the length units. We're going to minus 1 off this length unit. Let's come back and look at the span end. So we want spreadsheet dot horizontal spacing, which is 8 times, and then we're looking at the units, which is spreadsheet dot. Now this is length, so length units. You can see we've got 24 at the moment. Let's minus 1. Let's go in 23, so we're going to need a bracket around this last one with the minus 1, and we get our 16. I hit OK now and click off. We can see that we have those 2 fillets in there. Let's come back into the linear array and resolve the count. So we come down, we can see our count is at the moment just 2, and these are the spreadsheet width units which we've set to. So this is where we've got confused. So we can just quickly change this and set this to the length units. Hit OK and click off, and we fix that problem there. So we've got our first array. So it's an array of features, that fillet, array of fillets. So when we change our spreadsheet to length unit of say 4, we see that's starting to work there. Let's go one step further and now use the width. For that, I'm going to need another linear array, and I'm going to use this as the element to array against. Make sure nothing's selected and add a linear array. Now you can see the kites have been added, but they're along the wrong axis, so they're going this way along the X. We need them to go along the Y, this way. If we look at this linear array and come down, we can see we've got the step, the span, start, etc. We move our way up, we've got something called reverse. That's important if these are pointing in the wrong direction. So if I reverse this, this will actually go this way rather than this way. Come up further, we've got the direction. So we come into here, it has a 1 upon the X. So look at the X, it's saying to go along the X fully. So all we do is 0 out the X, and we want to place it along the Y. Place a 1 along that Y, and you'll notice that these are now flipped. So they're on the Y axis. It's pointing in the wrong direction, so we could use our reverse, or we could set the Y to -1. And now that's pointing in the right direction. Let's shrink this down. We're going to do the same as we did before, but we're going to use the populate linear array, the actual object we created with that fillet, against this linear array. So click on our object. We'll shrink out to save us getting confused with the other linear array within there, and then control click the other linear array and see they're both highlighted. And we're going to make an array of basically this compound object, or this array. Again, come up to Lattice 2, populate with copies, and then populate with copies build array. And you can see we've got this compound object, or this array, actually duplicated it up again, and we've got a new icon over here. Reason why it's done it 5 times is because if we come into the object that's been created and look at that linear array, making sure we get the right one, we've got number of elements 5. We need to change that. So come down and we're looking for the count. Again, we're going to hook this up to the spreadsheet by using the formula editor and spreadsheet width units and hit OK. Click off. We've got the 2, but we've got to update our span. So remember, we've got the span here on that linear array. And if we come down, the generator should be span n, and we need to change the span end. So we're going to use the formula for that, and that's going to be spreadsheet dot horizontal spacing and then times, and then in brackets the spreadsheet dot width units -1 and hit enter. We get 8 in here. When we click off, we now get our second row. So I'm going to save this and do a bit of testing. So we've got the width units are 2 and length units are 4. Let's set this to something like 8 and 8. And we can see that's working nicely now. And if we set this to our minimum value, so let's come back to the spreadsheet, click on the tab and set this to 2 and 2. Come back, we get the 4 studs in there. So we're going to move on to the tube on the bottom now. So let's flip this over and look at the bottom. That's hide this linear array here by pressing the spacebar, and also come into this object that's nested in the previous object and hide that linear array as well. You can actually select them from the screen and press the spacebar to make that a lot easier. We've still got the thickness, so we're going to reference this, and this is what we're going to add the sketch to. So let's come over to the sketcher. I'm going to select the inside face here, and this should be the thickness, remembering that the thickness, the amount of faces, won't change. It'll just change in size and dimensions when we change that spreadsheet. No extra edges will be added or extra faces, so this is safe. Make sure we select that face on the bottom and create a new sketch. Go flat face, hit OK, and we're going to use the circle and create 2 circles that are constrained to that center. So an outer and an inner circle. And also hit escape. I'm going to use the import geometry and import that top left point here. So we can see that's sitting on that sketch there. Let's have a look at the diameters of the tube. At the moment, that's not in our spreadsheet, so we need to reference back to our technical drawing to actually add these. Now, if you notice, I'm adding them while the sketch is still open, so I can open that tab and add them there. Looking at our technical drawing, we can see that we have the diameter here. We've got inner diameter of 6.5 and an outer diameter of 4.8. And these are the tube inner and tube outer. Also, we've got a placement, so it's 7.9 away from this side, and this will be the same this way as well. Let's add these to our spreadsheet. So we have the tube inner, the tube outer, and the tube placement. Tube inner is 4.8, tube outer is 6.5, and the tube placement is 7.9. I'm going to alias up these values using these labels here. And now we can use these in our sketch. Just going to save and come over to our sketch. Hit escape, and you can see that we've got the circles constrained to the center. Let's deal with these tubes. So let's set the inner diameter. by using the diameter, formula editor, and spreadsheet dot tube inner. Hit OK, and then set the tube outer. And hit OK. So now we've got those in there. When we pad these, it will make the tube that we need, and we're going to follow this edge so it takes it all the way to the top. Let's hit close. We need to be over in the part workbench to allow us to pad this. Make sure the sketch is selected and click the pad. I'm going to go along edge and select an edge. I'm going to select this edge in here. We click and hit OK. The feature has been padded to the height of that edge. So we've got the extrusion here, the extruded tube, and we just name that tube extrude and hit enter. Following an edge means that when this changes in height, if I use the spreadsheet and say change the height units to say 1 and come back, you can see how that's changed there. We'll now use this tube in the Lattice2 workbench. Let's come over to the Lattice2. And let's give the spreadsheet some different dimensions. So let's change the width dimensions to say 4. And we'll leave the other one as 2. You can see what's happened there. It's pushed it this way. Let's click off and add our linear array. So we've got the same linear array there. Let's change the linear array to go in this direction. We're actually doing it a different way around to what we did previously before. But you see that we've got a problem in that because we've added that circle to the center, the span actually goes from the center and moves out rather than it going from over here. So let's change this first to go in the right direction. So let's come up to the direction, come in here, and we want this to go along the Y. So we change this Y to 1. First, make sure we 0 the X and then place a 1 in the Y, like so. So what we could do is change the span start. At the moment, it's 0 millimeters. If we change this to -10, then that moves it backwards, like so. The thing is that I really want this over here, just to keep things simple. So I'm going to show you how to change that now. We've already got the extrusion on the tube. Come in here, we'll look at the sketch. Double click the sketch. I'm going to come into the sketch and zoom in to the center point here. Now our kite, if I come down and look at that linear array, this one here, press the space bar, that's out the way so we can see what we're doing. I'm going to click on that center point and hit delete. As you can see, these have been turned white. That means they're not constrained, they're not green anymore, and we can move these about. Let's move this up. And we're going to move it up here, and we're going to constrain this to the top left. So using the import geometry and bring in that top left here. Now this should be the thickness that's coming in here. So click on that top left, and now we can set some parameters against a point there. Hit escape. Take these 2 points, set a length, use the formula editor, and type in spreadsheet. And this is going to be the tube placement, 7.9. Hit OK and OK again. We're now going to do the same from this point and this point for the height. Again, using the formula editor and spreadsheet, tube placement. Hit OK, OK again. And now we just can use this center point and the center point of our circle. First, let's move our circle so it's closer, and use this point and this point. So those two have been marked as green and make them coincident to each other. If we didn't move this circle away from this center point, we may have caught this center point by accident. Let's hit close. Everything will be recomputed. And now when we use our linear array, this one here, we don't have to use the span start. So we can set this back to 0. Let's use the formula editor against the span end. So this is going along the Y, which is the width, X is the length. So spreadsheet dot horizontal spacing times, and in brackets, spreadsheet width units -1, and hit OK. That's been added in there, and now we can go to the linear array and come into the count and set this to spreadsheet dot width units. So you'll notice this will be 4. If I hit OK and click off, we have that count in there. It actually needs to be 3. So let's come into that count and -1 from here. Click off, we got the 3. And also we need to come back in and change the span end as well. And we're going to -2 from this. So before we -1, now we're going to -2 and click off. Now when we do the array in against this, we should have the right amount of tubes in the right position. To do that, we're going to use the tube extrude, control click the linear array, come up to Lattice2, populate with copies, and populate with copies build array. Click off, and those are now in there. They're in the right position, and we can test the spreadsheet once again. Now at this point we can place the spreadsheet and our project tab side by side if we want to test them. That's easily done by clicking on Windows, Tile, and we get them side by side. So we can see what we're doing, so we can change the values in our spreadsheet and see the effects that it has. So at the moment we've done our width units. If we set that to 2, the smallest, it will still be 1. And set that to 4. We've got 3 on that side, and we've got the studs on the other side. Now the only thing is now is that when we change the length units, let's say to 3, we need another row of tubes on this side. Again, I'm going to click, make sure nothing's selected, and we're going to bring this out. See how they swap positions? It can be a bit annoying sometimes. So we've got more space to work with, and we can just shrink these down and bring these out a bit more. Something like that. What I'm going to do is make sure nothing's selected and create another linear array. So linear array, span /n, or use the icon up here. You'll notice that if we drop this down, we've got the options here as well. You can see this is going in the right position. So it's gone from the center point outwards. That linear array there, it's in the right direction along the X. And we can populate the formulas in here. But first of all, I'm going to take this object, control click the linear array, come up to Lattice2, populate with copies, populate with copies build array. So we've started our array of objects, and then I can drill into that new object that's been created and click the linear array. Now we'll change the count and the offset. First of all, let's do the count. So we're dealing with the length in here. Spreadsheet dot length units -1. Yeah, okay. Click off, we got the 2, and then come into the linear array, and that's changed the span. Make sure that when we come down, the generator mode is span n. Span end needs to be the spreadsheet dot horizontal spacing and times that in brackets length units, which is spreadsheet dot length units and then we minus that by 2. Hit enter and click, and now we've got the tubes in there. So when we change our length units, say 5, we get the right amount of tubes. And as you can see, we have now got a parametric studs and tubes that all work fine. There's one more feature that we need adding, and that's the little nubs in here that stop the brick from coming apart too easily. So when we add 2 bricks together, it holds them in place. Now this is the good thing about a part workflow. We're using Lattice 2 and part workflow, is that when I want to add these nubs, if I click on the inner part here, this is still the thickness. If this was something like the part design, then this will be the last action. So our last action would have been these populate linear array if it was part of that part design, which is not. Therefore we get problems with topological naming issues, and we have to keep on referencing back towards the base, the very first or the second action in our list. Because this thickness is still available, then we can use that. When we start fusing this together in our last actions, then this thickness will bury itself within the tree, but we can still get to it. Let's click on the kites and press the space bar because we don't need those anymore. I'm going to come up to the window and click on tile again, and that will position these side by side. So it's distributed the width of the windows between them equally. Close this spreadsheet down. It's still available. I know it's not saved. It's still saved as part of the project. So I've hit Control S. Our values are still saved there. And I'm going to maximize this screen to get this one back. Let's add the nubs. Again, I'm going to use this face within here, the thickness, that same face, and come into the sketcher and create a sketch. Flat face, okay. Now the nubs are very simple. They are just a rectangle, but we're going to use the centered rectangle, this one here, and create our sketch. Now let's bring in some geometry. I'm going to bring in top left hand corner, import the geometry using the external geometry tool, and bring in this top left. I can set some distance away from this, so this point and this point. We're using the distance, and this is going to be the spreadsheet dot wall, and hit OK. Hit OK again. I could have brought in this line, but I've just done it from the spreadsheet here. So that's in there now. Let's come back and look at this spreadsheet. We haven't got any parameters for that nub yet. So let's look back at our technical drawing. You can see we've got the nub width and the nub height, and they're quite small. And this nub centered to top left, which is 3.9. Let's get these values in. So we've got nub width, nub height, and nub center to top left. Bring these out a bit so I can see them, and let's get the values in here. So we've got 0.6 and 0.2 and 3.9. So 0.6, 0.2 and 3.9. Let's alias these up. Pressing enter each time to make sure the values are saved. Now those values are in there, we can transfer those to our model. Taking the center point, and here we can set a length. Using the formula as spreadsheet dot nub to top left. Now let's zoom in and set a length here. We've already got the length selected because I selected from the top first. So I'm going to set the length on this one. Using the formula editor, spreadsheet, nub, width. and we use the height against here, and this one's going to be spreadsheet dot nub height. Okay, that. So we have the nub in there. We're going to do the same on the other side. So now we've got this nub in, let's do the same on the other side. So we're going to create basically a mirror of it over here. To do that, I'm just going to sketch straight into this sketch here by using the center rectangle. And we'll place one in here. Now to cut down on datum constraints, I'm going to take some equality across the bottom lines, make those equal, and do them across these vertical lines as well, make those equal. Also going to take this point and put those in line. So the only constraint we need is to the bottom left hand corner. Let's come down and import that bottom left hand corner using the external geometry tool, and then we can take the center point. Let's bring this down. As you can see, if I do this, I can't move it from the left to right. So the only constraint that I need is to constrain it to the bottom. Let's bring this down and finally zoom in and take this point and this point. We'll set a length, and this one will be spreadsheet dot wall. And hit OK, and OK that. Let's place that against that edge there. We can now come over to the task and close that and extrude that nub. So selecting the sketch, and in the part workbench, we use the extrude, selecting a long edge, because we're going to use this edge in here, hit select, and now we can select that edge there, and hit OK. That's extruded up, and you'll notice in the extrude that we're referencing the thickness edge 19 once again. So that was the same for this one as well. If we come into here and look at the extrude, tube extrude, you see we've got the thickness edge 19. And this edge, no matter how big or how small this thickness or the actual extrude within, which is controlled by the spreadsheet, if that changes, then we won't get into that topological issue, because the amount of faces still stay the same and the amount of edges stay the same as well. I'm now going to use the Lattice2 Workbench. And again, I'm going to make sure that nothing is selected. Let's shrink these up so we can see what's happening. So nothing selected, just selected some blank space there. Lattice2, and we're going to come down to the linear array and the linear array span /n. We've got that added to 0.000. Now we can add our formula to repeat this across this way. So let's first take the linear array and the extrude and come up to Lattice2, populate with copies, build array. Let's add those in there. Now we've got to figure out our formula. The easy part of the formula is to take that linear array. So we've got this new object in here. Within that, we've got a linear array. This is this one here. And we'll come down to the number of elements. And this one, now this is read only, so it's actually coming down to the count. That will catch you out a number of times. And this is going to be the same amount as the nubs on the other side. So we've got the 5 going across this way. So this is going to be the same amount. So we come into our formula editor and add spreadsheet dot length units. Hit OK. So that's those in there. Now we need to add the span. So click back on the linear array. Come down to the span n. So we've got generator of span n, which is correct. And now to the span end. Formula in there. And we need to take the spreadsheet dot length. And we need to minus from that. And in brackets, I'm going to put spreadsheet dot. And this will be the nub centered top left, so that's the length of how far it is away from this top left here. So we've got this distance, and then we times that by 2, making sure we use the asterisks. So we've got 32 there. So we're taking the length and then just minusing off this bit here and this bit here. Let's hit OK and click, and we can see that's taken. So that's our first set of nubs. We've got to do the same here as well. So we need 2 nubs here. It's going to be the same distance away. It's basically the same process, but we're doing it with the width rather than the length. So let's do that now. Let's come over to the sketcher. And again, we're going to select this face inside, which is the thickness, and create a new sketch. Flat face, OK. So now we're in the sketch. Let's add these nubs to here. So add the rectangle, hit escape, import that top left geometry, that vertex there, and then place this a distance away using the height and using the formula editor, using spreadsheet dot nub, centered to top left, and OK. That's in. Let's do the wall. So we're taking this point and this point, placing a length, back to the formula editor and spreadsheet, and we want wall. OK, that's placed. Now we need to set the length, and this is going to be the shortest side. So spreadsheet nub. Come down, we can see the values are here, so 0.2, which is nub height. OK. And finally, we need to come into this length here, and this is going to be the longest side. So spreadsheet, and that one's nub width. And OK that. So that's in position. We now need another one. So another centered rectangle, and this is going to be on the other side, so over here. And it's going to be the mirror of this. So I'm going to take this point and this point to keep them in line, and take this edge and this edge, place those equal, and also we need the length as well. So let's take this edge and this edge, make those equal. Cuts down on the data constraints. And we just take this point and come over to the other side, and we need to import the top right point now. So we've got those there, and because we're working at quite a small scale, it's quite hard to see. Let's take this point and come over. That point's still selected, so this point, and set a length. Come into the spreadsheet dot wall. That should bring this over to this side and attach it to this length here. So we're all set. This is going to be patterned down here. So let's hit close. First thing we need to do is the extrude. So come over to the part, and let's have a look, see what we got. And we can see those in there. If I click off, we can see the little white sketch in there. Click on that sketch, use the extrude. We want a long edge, and we want to select this edge in here. So we're selecting the same edge as we did before. Thickness edge 19, that comes in. So this is the same edge as these tubes as well. So we're referencing back to that geometry that doesn't change in the amount of faces and the amount of edges. So that's extruded down. And we'll see that extruded on both sides because it's a single sketch. And now we can add our array in the Lattice Workbench. So come over to the Lattice Workbench. Make sure nothing's selected. Lattice 2, linear array, and linear array span n. It's going to go in the wrong direction, so you can see it's been added there. Now before, remember, we changed the direction. So linear array needs to come this way. So this is the direction. Here we go, here, and we want to zero out the X. Always zero them out first, because otherwise it starts to recalculate the values. And we want this to go along the Y this way. So place a 1 in the Y. If it goes the wrong way, then use a minus value or use the reverse. Now we've added that, let's scroll down and find our count. So the count is just going to be the spreadsheet dot width units, which is 2. And the span n, come down, got the span n, generate span n, make sure that's set. And the span end is spreadsheet dot width, and then we're minusing off in brackets the spreadsheet dot nub to center top left, and times that by 2. So now we've got that, hit OK, and that's in there. So we're ready to array against these. Take the extrusion, which is our side nub extrude, just name that quickly, and control select the linear array. Come up to Lattice 2, populate with copies, populate copies, build array. And if we click off, we can see that's been added. Let's hide these kites. So click on them, press the space bar, and the same with this one. We're almost finished our model. Quick check. Remember to save as you go. So we've got the width as 2. Let's set this to 4. And we can see that's working in there. So we've got this far, and now we want to output this to, say, a 3D printer, or we want to use it in another 3D package, or you might even want to add some boolean operations against it. So you need to create a solid. There are many options now, because these are linear array operations that are Lattice 2 operations, but they need to be converted to allow us to do any boolean operations or to export out. Well, saying export out, we can actually get away with taking all of these by control clicking them or shift clicking them all, taking the thickness and all the linear arrays, and then in the part workbench we can just come over to part compound and make compound, and this can be exported out by going to the file and export it as an STL file. And we'll save that and replace what's already there. And when we import that file, import, then we can bring in our STL file and open that up. And if I press the spacebar on the compound, you can see that STL file is there. So we get a valid export. Now you can use whatever export you want in there. I just use STL. I'm just going to get rid of that file and bring back the compound and delete the compound to release the objects inside. We can highlight these, shift click them all, and go file export in the same way, and that will take those as a compound actually on export. If we wanted to do some boolean operations against this, say we want to remove a sphere from in here or remove parts of this object with a cut operation, then we have to prepare the model. So we come over to the Lattice 2 and we have to convert these to a more simpler object. It's going to be a parametric downgrade. Now you see this in the draft workbench, but it's not parametric. So we come up to the Lattice 2 and look at parametric downgrade. We've got this downgrade to leaves. And that's the simplest object that can be downgraded to. And then we've got downgrade to such things as solids, shells, open wires, etc. Let's just take the default downgrade to leaves, and you can see we've got that one there. Let's do the rest. And I'm going to use the icon on the toolbar, downgrade to leaves, and this one again, and keep going all the way through all of those linear arrays. Now we've got all of those, we need to create a compound of these to fusion them together. So we highlight them all. Lattice 2 Workbench offers compounding tools, Lattice 2, and we've got this make compound. Also, we've got the fuse compound, and this is the route we're taking. So make compound, and then we click on that compound out to the Lattice 2 and down to the fuse compound. We've now got a solid object. You can see this refinement there, which means that if we had a number of faces going across here, we can use the refinement to get rid of that and just have one single face. So as long as it's along the same plane, we're okay. Let's come over to the part workbench and test this model now. So I'm going to add a sphere. I'm going to increase the sphere, something like 15 millimeters, and then I'm going to use that sphere. First of all, click on the one I want to keep, which is the Lego brick, and then the one I want to remove, and use a cut. If we look at our model now, it's actually had that sphere cut out of it. We do have some floating objects there, and that's where the sphere just touched those objects and just removed them. So this just shows you that this brick is now boolean ready. So we can do what we want with this. Again, it's still parametric. So if I increase this, say by the height of 8, and then click off, come back, we can see that's increased in height. If we look inside, we've got our boolean operation that's taken place within. So fully parametric there. Let's get rid of that cut and delete the sphere. Can come up to the window and tile window. So we've got a solid object that we can change on the fly. I'm just going to set that back to 3. And there we go. So there you have it. The end result using the Lattice2 workflow with a spreadsheet and the part workbench to create a fully parametric Lego brick. I hope you've enjoyed this video, and I hope to see you again soon. If you like what you've seen, please subscribe to the site. I also have a Ko-Fi or a coffee site that you can donate to if you so desire, and that's at ko-fi.com/MANG0. I also run a Patreon where you can subscribe and get extra content, and that's at www.patreon.com/MangoJellySolutions. Any money that's kindly donated will be used to expand the channel. Thanks a lot for watching and subscribing, and I'll see you again soon.